Hello, a warm welcome to all. Stability certificate. Today I am going to discuss about the health monitoring of structures by which we will have to analyze the stability of the building and we can issue the stability certificate. I have divided it into 4 parts on the stability of structures. Part 1, basic introduction. Part 2, awareness of present practice. Part 3, what is required. Part 4, what shall be done. Please note, in this session only part 1 is covered. Please subscribe to my YouTube channel and share with others to get more knowledge. Part 1, basic introduction. A very important subject and interesting too. What is a structure? In civil engineering, a structure is built to serve its intended purpose. It may be a building, road, bridge, dam, irrigation structure, or any other related element. A structure can be constructed using different materials such as mud, stone, wood, steel, or reinforced cement concrete, that is RCC, etc. It is being covered in all the 4 parts only on industrial buildings. Life of a structure. It is the period of a structure for which it has been designed and constructed to function well for the intended use throughout that period. The life of a structure varies with its nature, intended use, importance, location, and climatic conditions. What are the factors on which the life of a structure depend? Quality of design, quality of materials, quality of construction, quality maintenance. More precisely, to say that it is the quality of persons involved in all these. It means the knowledge, experience, and the dedication of the persons involved in all the above 4 factors decide the quality of structures. So, altogether, as a quality team can construct a quality structure. Quality of a structure. How to define? It is a structure with 0 defects. It is the structure which fulfills or exceeds all the needs, expectations, aspirations of the user. Quality is the fitness for the purpose. Quality is the adherence to the required standards in design, construction, and maintenance, etc. That is how the quality can be defined in so many terms. Health of a structure. What is the health of a structure? It is the strength, stability, serviceability, and performance, that is physical condition to perform well against environmental conditions of the locations and all the loads and forces for which it is designed. Then what is strength? It is the physical condition of a structure to resist the loads, forces for which it is designed without any distresses in its service life. Stability. What is stability? It is the ability of a structure to remain stable. This means the structure should maintain its original strength, position, and shape without any distress when the design loads and forces act upon it throughout its design life. Serviceability. It is the ability of a structure to serve its intended purpose throughout its design life without any distress, discomfort, damage, or inconvenience to the users, even if it possesses adequate strength and safety against collapse. Stability ensures the strength of the structure to resist against the loads and forces acting upon it, whereas the serviceability ensures its well performance and comfort during its normal usage. Performance. It is how well structure functions and meets its intended purpose in terms of safety, comfort, durability, efficiency, and usability even under extreme conditions throughout its service life. Quality of design. The quality design means designing a building or a structure for its intended use in par with standards, economically viable, aesthetically good, safe, well-functioning, and user-friendly. The following are the parameters which define the quality of a design. That is sustainability, durability, cost effectiveness, functionality, safety, aesthetics. All these factors, they decide the quality of design. Quality materials. Most of the factors like sustainability, durability, safety, and performance mainly depend upon the quality of materials used to build a building or a structure in addition to the quality design. Many times, the quality of materials define the cost effectiveness. It is obvious that quality materials are costlier than usual conventional materials. So, quality is directly proportional to the cost of materials. However, in these modern days, challenge is to get the better quality materials at the lower cost. This is how several innovative materials have come in the market. Quality materials. Therefore, one should be aware and update his or her knowledge looking at the recent development in science and technologies. Quality construction. It is not enough to get a sustainable and durable building only having quality design and quality materials. The construction process plays a crucial role in getting a stable, safe and durable building. The quality construction involves the following. Quality management requires standard procedures, quality control and quality assurance from materials up to final product, strict and quality supervision, skilled laborers and supervisors, safety audit, product performance with completion report. Quality maintenance. The maintenance of a building plays a vital role in achieving sustainability, durability and functionality. In many cases, more importance is given in the beginning to quality planning, quality design, quality materials and quality construction, while neglecting a very important aspect, that is quality maintenance. Quality maintenance forms the foundation for ensuring stability, durability and functionality throughout a building's service life. Maintenance is a long-term activity carried out continuously over the service period of a building or structure and requires proper and sincere attention. Quality maintenance. The maintenance activities are basically classified as below. Routine maintenance, that is day-to-day maintenance. Periodic maintenance, specific period the structure will have to be maintained. So that is periodic maintenance. Annual maintenance. Every year specific maintenance activities will have to be taken place, which is annual maintenance. Seasonal maintenance, that is according to the season. For example, before monsoon and after monsoon, many of the maintenance activities will have to be taken, which are very, very important. Situational maintenance. This is not certain, it is very uncertain. If the situation warrants a specific maintenance of a structure or a building, we will have to take up that maintenance immediately. Problems in building maintenance. Industrial buildings are generally complex in nature and are composite structures built with steel and concrete. These buildings are subjected to heavy loading, vibrations and chemical reactions, in addition to the usual climatic conditions, soil characteristics and the quality of design and construction. Therefore, the common failures in steel and concrete structures must be studied in depth to identify their root causes to address them effectively. Problems in buildings. The problems may be classified as below: structural problems, mechanical and electrical problems, water supply and sanitary problems, environmental problems, safety problems, material degradation and surface problems. So we shall see one by one. Structural failures. General structural components of a building are footings, columns, plinth or grade beams, lintels, canopy, roof beam, slabs. These are general components. Apart from this, there may be other components also, depending on the design and planning by the architect and the engineer. Problems in building. Footings. Ultimately, the superstructure load will be transferred to the footings and then to the natural ground beneath. Footing fails when it is not capable of transferring the load safely to the natural ground. Failures may be structural failure. It is because of inadequate thickness or inadequate steel or poor concrete, improper and insufficient curing and overloading beyond the design load. Nature of failures. Settlement may be informed settlement or it may be differential settlement. Cracks in footing and in superstructure. Settlement, if it is informed, it may not affect much, but differential settlement definitely affects a lot and structure may collapse. The next, punching shear failure. Due to insufficient thickness of footing, use of poor concrete, insufficient reinforcement around the column will be the reason for punching shear failure. Problems in buildings continued. Bending failure in footing slab. Due to inadequate steel, poor concrete, inappropriate soil investigation will be the reason for bending failure in footing slab. Overturning. This is due to eccentric loading or uneven soil reaction. Uplift or heaving. Footing will be lifted due to upward force exerted due to swelling of soil like BC soil. Corrosion. Due to chemical effect, insufficient cover, sulfate attack from soil. Failures in columns. Plumb out of columns. This is because of errors in construction. Buckling of column, especially in case of long columns. Due to heavy loads, beyond design loads, insufficient confinement, improper compaction, leading to honeycombs, corrosion of steel and erroneous design, eccentric beam, column junctions, etc. And if slenderness ratio is not properly maintained, that will also cause buckling of columns. Plinth or grade beams. This is excess deflection beyond the permissible limit, vertical, horizontal and inclined, that is shear cracks. Reasons for this, that is insufficient sections, inadequate steel, excess loading, poor concrete and insufficient compaction. Lintel, excess deflection beyond the permissible limit, it may develop cracks. The reason for this is insufficient sections, improper compaction, inadequate steel and design errors. Canopy, deflection beyond permissible limit, development of cracks, spalling of concrete. Reasons for this are erroneous design, improper compaction, improper curing, etc. Roof beams, excess deflection beyond the permissible limit. Cracks will also be developed. The reason for this is insufficient sections, improper compaction, inadequate steel, design errors. Slabs, common failures are cracks, spalling of concrete, leakage, excessive deflections, corrosion of steel. A reason for this are improper cover, insufficient compaction, insufficient curing, insufficient drainage system or poor concrete. Mechanical and electrical problems. Mechanical, corrosion of machines, trusses, steel pipelines, turbines, machine foundations, corrosion of trolley railings, shafts, couplings, gantries, trolleys, cranes, crankshafts, etc. will be corroded because of climatic condition or chemical reaction in the factory. Electrical failure. They are short circuits, shutdown due to overloading, loose wiring, wires coming in the contact with moisture, overhanging bunches of wires, loose connections, improper insulation and voltage fluctuations are the causes for electrical failure. Water supply and sanitary problems. Water supply problem. Common problem is leakage of pipes due to overpressure, improper joints, use of insufficient pressure gauge pipes, water hammer effect, corrosion in case of steel and GI pipelines. Sanitary failures. Common problems are choking of pipes due to debris by plastic, cloths and other non-degradable materials. Bursting of pipes due to pressure created beyond the design pressure. Silting of pipes due to entry of storm water through manhole joints. Environmental problems. This is due to excess rain, earthquakes, storm, climatic changes, etc., which will cause the structure to fail or deteriorate. Safety problems. This is because of insufficient safety systems for men and materials, untrained safety personnel, inadequate safety awareness program, improper safety for explosive materials, inadequate safety arrangements, etc. Degradation and surface problems. Improper degradation, material storage. Surface problem. Plaster cracks, fading of paints, undulations of surface, dampness in surface, spalling of tiles, differential settlement in floorings due to which undulations in the tiles and spalling of dead end, etc. Common spots of failures or defects in buildings. Common locations of failures you can observe. Generally, there are cracks within the building foundation, cracks in columns, cracks in beams, cracks in slabs, dampness in walls, dampness in slabs, cracks in column beam joints, leakages in joint slabs, choking of sanitary pipeline, leakage of pipe joints in pipelines and sanitary lines, growth of shrubs, grass on slab, chajja, canopy, etc. Cracks in walls along the concealed electric pipes, cracks in walls at horns of windows and doors. Horns means the extended frame structure of window and doors inside the wall. Cracks and undulations in floorings, cracks and corrosion in steel structures. That's it. In my next session, I am going to create awareness on present practice in getting stability certificate. Please subscribe to my YouTube channel and share with others with a request for a subscription. Thank you.